So the EMF induced here is an AC EMF, not a DC. So how the chapter is about DC machines. So how we can answer this? So how we can make this machine as DC, not AC? So the generated EMF is AC, it's sine wave, and we need to convert it to DC. So how we can do this? So this is a very smart idea that they did it back in the 19th century, and this was the first rectifier ever, but this rectifier was a mechanical rectifier that can convert from AC to DC. And here is the idea, okay? So we said that we have a coil, and this coil has two sides, and we are adding one ring for each side. And instead of doing this, they did the following. They used a cylinder that is divided into two halves, and between the two halves there is an insulation here. So there is no electrical connection between the top half here and the bottom half. Okay, so this half of the cylinder is electrically insulated from this half of the cylinder. And they added the two brushes here. So they added a brush here and they added a brush here. So instead of using two rings, so this is brush and this is brush, and this is half and this is half, and here we have insulation. So don't forget that the coil is rotating and this two halves are rotating while the brush is stationary. So these brushes are stationary. So what will happen if we have this kind of structure? Okay. Now let's name these ends as A, B, C, and D. And let's take this structure into the different positions. So let's name this voltage as E1, and let's name this voltage as E2. And as you can see here, E1 is going in this direction while E2 is going in this direction. So E1 and E2 are negative. So the relation between E1 is negative E2, and you can see this because of the angle between the two sides. So the angle between this side and this side of the coil, this angle is 180 degree. So if E1 has an angle theta 1 and E2 has an angle theta 2, the angle theta 2 is 180 plus theta 1, which is the shift between the two coils or the two sides of the coil. So E1 is negative E2, or if the first side of the coil is under a north pole, the second side of the coil is under a south pole. So if the flux here is leaving the north, the flux here is entering the south. So when you use the right hand rule to find the directions, you will find the direction of this E will be opposite to this E. and this coil is moving in this direction because of the rotation, so this one will be moving in the other direction. So the 2MF across the two sides of the coils, they are in opposite directions. Now if we need to sketch E1 and E2, versus time, so E1 will be a sine wave. So this is E1 versus time. So if we need to sketch E2, it will be the same wave but flipped, because the angle shift between them is 180 degree. So this is E2 and this is E1. Now if we need to sketch the voltage, but we need to sketch the voltage across the brush, not the voltage of E1 and E2. Now if we need to sketch the voltage across the brush, so here is negative, positive E1, here is negative, positive E2, and let's take this at time t1, and let's sketch the same circuit but at time t2. So this is at time t1. Let's sketch it again at time t2, and t2 is after rotating 180 degree. So after rotating with 180 degree, we will have E2 up and we will have E1 down. So after 180 degree, we will have E1 going down and we will have E2 up. If you look at the brush here, the brush here is negative, this brush, and this brush is positive. If you look at the brush here, it's negative, and this brush here is positive. So as you can see that this brush is positive for all the time, and this brush here, so sorry, this one is negative for all the time, and this one is positive for all the time. Or if you have a cylinder which has two halves, and this is, let's name this half as H1 and this one as H2. So this one is H1 and this one is H2. After 180 degree, they will change position. So this one will be H1 and this one will be H2. So the brush here, this brush will touch H1 for 180 degree because this cylinder is rotating while the brush is stationary. So the brush will touch this cylinder for 180 degree, and then after 180 degree it will be touching H2. So if we name this as brush 1 and we need to sketch the voltage for brush 1, so if we need to sketch the voltage for brush 1, so brush 1 is touching H1 for 180 degree. So for 180 degree, brush 1 is touching H1. Then for 180 degree, brush 1 is touching H2. Then for 180 degree, it will be touching H1 and then H2 and so on. So when brush 1 is touching H1, it is connecting to E1. Okay, so it is connected to E1. When brush 1 is touching H2, its voltage is equal to E2. So here V brush 1 equal to E1 and here V brush 2 equal to E2. So the voltage across brush 1 will be E1 for 180 degree. Then after 180 degree, it will leave E1 and it will be touching E2. So if we sketch V brush 1, it will be E1 for 180 degree. Then it will be E2 for 180 degree. Then it will be E1 for 180 degree and so on. If we need to sketch V brush 2, so when brush 1 is touching H1, brush 2 is touching H2, or V brush 2 is E2. When brush 1 is touching H2, brush 2 will be touching H1, or V brush 1 is E1, and so on. So in this case, if we sketch brush 2, it will be E1, sorry, E2, then it will be E1. So here is E1, then E2, then E1. Here it is E2 first, E2, then E1, and so on. So as you can see that the brush voltage here is always positive and the brush voltage here is always negative. By the way, I should sketch E1 and E2 flipped because E1 is the negative one and E2 is the positive one, but doesn't matter, just the signs are flipped. So as you can see that V brush 1 is always positive and V brush 2 is always negative. Now if you take the voltage between the two brushes, V total, which is the voltage between the two brushes, so this is brush 1, here is brush 2. Now if you take the voltage between brush 1 and brush 2, V total, it will be the difference between E1 minus E2, and as E2 is negative, it will be 2E max. And as you can see, V total is DC, direct current. Direct current means one polarity, it's always positive. So now we have our voltage output, or our voltage for this kind of machine, as DC. So the change from AC to DC is done by using the cylinder made of two halves, which is called commutator. And it is called commutator because you are commuting from one half to another half. The brush is commuting from one half to another half. So the commutator acts as a mechanical rectifier that converts from AC to DC. So this is the basic part of DC machines, is the commutator, which converts from AC to DC. So if we look here, this is the same structure that we did before, but with, instead of slip rings, it is made with the two halves. So we did this with slip ring here. You can see here two complete rings, and now we will do this with the two halves. So as you can see, so if this is A, B, this is A, B, so you can see that this terminal here is rotating. So this terminal here is rotating, this terminal here is rotating, and this terminal here is rotating. Okay, so we are assuming we are moving in this direction. So in this case, if the voltage in AB reaches E max positive, then the voltage of AB is reaching a 0. If you look at this brush here, you can see that this brush here is now moving from the first one, from this one here to this one here. So look at this brush. So it is touching the first half, and after 180 it is touching the second half. And the first half here was connected, or was under a south pole. So, and here the second half is under a south pole. So this brush is always touching the coil under south pole, which means it has only one polarity. It is not switching polarity. But if we go up to this case here, and if you look at this ring, and this ring is soldered to, or this ring is touching, this brush, sorry, is touching this ring, and this ring is connected to this side of the coil, and this coil will be under north and under south, which means that the brush will see two different polarities. So to convert from AC to DC, simply instead of using a ring, use two halves, and you can see that the output voltage is rectified. So this voltage is DC. So you have an AC voltage generated E. So if you have a ring connected to the wire, and this is V of the wire, and you are touching this ring, so you will touch this ring for 360 degrees. So the collected voltage will be a sine wave. This is E collected. Instead of doing this, if V wire is still AC, but you are touching this voltage half of the cycle for 180 degrees using the brush, so the voltage you are collecting will be only this half of the wave. This is E collected. And then after half of the time, you will switch from one ring to another ring to keep collecting the positive voltage. And this is the basic idea. So this is AC and this is DC. Now we will go to another issue now, that the AC voltage, sorry, the DC voltage is the DC voltage is the DC voltage pure. So the voltage we have here is DC. DC means direct current, and direct current means one polarity, which we achieved. But look, what is the difference between DC and pure DC? If this is V of t and this is time, this is DC. But if you sketch versus time and you sketch the voltage like this is pure DC. So pure means it is constant. So although this machine is a DC machine, but its voltage is not pure and its voltage is distorted. So this voltage is polluted DC. It has a lot of ripples. So this voltage is full of ripples. So the question is how to improve the DC voltage. How we can improve the DC voltage. And improving the DC voltage is a simple idea. So what we need to do to improve the DC voltage, so instead of having one coil and we have this cylinder divided into two halves, we can add, say, another coil making 180 degrees. So instead of having one coil, we can use two coils shifted by 180 degree, and we will connect them, and instead of having here two halves, we will have 4 quarters. So here this cylinder will be divided into 4 parts, and we will connect these two here, one up and one down. Sorry, this has to be separated by 180 degree. So let's just do it with different colors. So this is the first coil. We will add another coil vertical, and we will have the cylinder here divided into 4 halves, and then we will connect this one here and this one here, and then we will connect this one here and this one here. And here we have 4 EMF. So this is E1, E2, E3, and E4. And you can see that the angle between E1 and E2 is 90 degree. So you have E1, then you have E2 after 90 degree, then E3, then E4. So if we sketch like this, these are the coils. So we start by E1, E2, E3, E4, and between them we have 90 degrees. So if you have a brush here and you have another brush here, so each brush is touching this half or this part of the cylinder for 90 degree. So now if we sketch E1, E2, E3, so let's say this voltage is E1, and this voltage is shifted by 90 degree. So this voltage is E2, and this voltage is shifted by 90 degree, and this voltage is E3. And you can see between E1 and the E3 there is 180 degree, and you can see that E3 is the inverse of E1 on this graph here. And let's sketch E4. Now the brush will touch each voltage for 90 degree, and 90 degree means 2 squares of these. Okay, this is 90 degree. So you will see that the voltage of the brush will be 90 degree of this E. Then at this point it will leave this E and go to the other E. Then at this point it will leave this E and go to other E, and so on. So if we sketch V brush 1, we can see that V brush 1 will be something like this. This is V brush 1. And if we sketch V brush 2, it will be the same thing but in negative. If you take the difference between V brush 1 and V brush 2, you will see a voltage like this. So this is V total. And you can see that V total has less ripples compared to the previous case. To have it even better, this is what we will do. So what we will do to have it pure DC, you can add more coils. And as you can see, each coil is attached to one part of this cylinder. And here between these cylinders, between these copper sheets, we have insulators. And each coil is attached to one of these. So this is one coil, this is another coil, and so on. So this is called commutator, which will convert from AC to DC. And whenever you see a commutator, you know this machine is a DC machine, okay? And these are the coils, and we are adding coils to reduce the ripples. So the more coils you have, so the angle here between the coils is less than 90, okay? Because you added more coils. The more coils you add, the smaller size of this copper, the smoother your voltage. So if this one is smaller, this means you have a smoother voltage, because you are touching this for less angle. And if you touch it for less angle here, so this is the angle of the oscillation, in this case is 90 degree. And when you take the difference, you can see the output voltage here. So if you open a DC machine and you look at the commutator, the smaller the segments, so these are the commutator segments, the smaller the segments, the better the voltage, okay? So if you look at this machine here, which is a higher rating, better machine, if we look at this machine here, you can see how many coils you have, and you can see how smaller is the segment here, which means this machine here has a better voltage compared to this machine here, okay? And this is what Tesla said. So what Tesla said, just if we remove this and we go back to a solid ring, a complete ring, and instead of having one ring, we will have two rings, one A ring and one B ring. We will go back to AC, and this is what Tesla did. Just he got rid of the commutator, okay? He didn't invent a new machine here. Just he said, okay, get rid of the commutator. But his invention, his breakthrough, was to remove the brushes. This is a totally different story. But converting from DC system to AC system, just what he said, just remove the commutator. So whenever you see a commutator in a machine, this machine is a DC machine. So we finished now the theory of operation and part of the construction. This part of the construction is called the rotor. Okay, so we finished the rotor construction, which is the rotating part inside the machine. And the rotor has the coils. So the rotor has the coils plus the commutator. So next lecture we will continue with the complete construction and we will go through the equations for DC machines. Thanks. So for the construction and theory of operation, we covered last lecture what are the main parts of the machine. So the machine, the DC machine, has two main parts. The first part is the outer body of the machine, okay, which we call it the stator part. And the second part of the machine is the part that will move, which is a rotating part. And there is a mechanical bearing between the stator part and the rotating part, so the rotating part can rotate. So the rotating part is attached here with a bearing, so there is a bearing carrying the or fixing the rotating part in place. So any machine will be constructed from stator part and rotating part. And as we mentioned last time, that we need to have a wire and we need a flux, and we need this wire to carry current for motors, or we need a wire and flux and we need to move the wire with mechanical force. So we have a generator. So these are the basic parts for motors and generators. So to get the flux, so first we need the flux and second we need the wire. So flux and wire, so these two parts are common between motor and generator. If you inject the current, the machine will be motor. If you move the wire, the machine will be generator. And this is the difference between machine and the motor. Machines means it can act as a motor or it can act as a generator. Last lecture we studied how we will design the wire or the rotating part. So we said that we will have a coil and this coil will be connected to a commutator. And we mentioned instead of having one coil, we will add many coils, and we will add these coils so we can have more smooth DC. And here we will have a cylinder, and this cylinder will have segments, and each coil will be connected to one of these segments, and we call these segments as commutator. And we mentioned that the commutator will convert from AC inside the machine into DC. So these coils actually are the wires we have. If we injected current here through the brushes, it will be a motor. If we rotated the coil, it will be a generator. So this can act as a motor or generator. And this part is the moving part. So this part is the moving part, which we will call it the rotor. And the well-known name for electrical machine area is armature. So we name this as the armature. And we cannot have a coil inside the machine rotating without a solid body. And to minimize the air gap inside the machine, the air gap here, we put this coil around a ferromagnetic cylinder. So this is a cylinder, and we have engraves or slots inside the cylinder, and we put our coils inside these engraved slots. So we start to do the winding inside the machine, and we will have the coil. So the coil will be done inside a cylinder from a ferromagnetic material. So we can reduce the air gap inside the machine. And again, we will call this the rotor or the armature. And this is the shape of a typical rotor of a DC machine.